Assalamualaikum and hi. Okay, so about the chain rule. So now is more, I would say more complicated chain rule. If you have multi layers and multi terms, then how is the rule that you have to follow, or the formula that you have to follow? So if we look at from here, if you have two variable function, okay, and just we have parameter t. So this is the case when you have, for example, yeah, we know that f is a function, for example, y, x and y. So this is z. Okay, the thing that you know always have is just x and y. So for example, the thing that we have discussed previously, you have ln of x plus y. Just you can see just x and y. Okay, but then what I'm saying, multi layers and plus multi terms, if you have z is a function of x and y, but y is the function of, for example, parameter t, and also x is the function of t, and y also is the function, another function in terms of t. For example here, okay, if z is ln of x plus y, but then x is, let's say, t squared, and then y is ln, I don't want to use ln again, so maybe sine t, then how can you find out or determine the del z over del x? Or maybe you want to know what is the del z over del y. Okay, but you, because of, in this case, you cannot just refer to this, just like we done before, because now your x is in terms of t and your y is in terms of t. But if you want to get the del z, del x, del z, del y, it's fine. But how about if you want to determine del maybe the dz over dt? But you have to remember the t here is under the x and y. Then how can you compute the derivatives of the z respect to t? So it is a bit something that you cannot just thinking directly. Then you have to know how or what is the step that you have to follow. So in this case, you need chain rule, but not the simple chain rule that you have done before. It is a longer. So because chain rule means formula, right? So you need a longer formula. So as you can see here, the formula is given like that. Okay, but how about you have a 3 layers? This is for 2 layers and 1 parameter. Then how about 3 layers and you have 2 parameters? So then it's become more complicated, more confusing, right? So now it is not important for you to just memorize this or another a longer formula or rule. The important thing here, you have to know how to construct this. So that is important. Once you know how to construct this, so anything that I give you, any kind of function, any kind of type of function or equation, then you can do easily. Okay, so now how can I want to teach you how can we have this formula without memorizing. Okay, so in this case, now we focus on 2 variable function with 1 parameter. Okay, so now the chain, you have to know how to have the chain. This is called the chain. Okay, but normally I'm not doing like this. So normally I just, this is from the left to the right, but for me I always use the from top to down. Okay, top to bottom. So the highest variable here, I would say the boss. Who is the boss? The boss is z, and who is under the z? Under the z is x and y. And then what is under x and y? We have the same parameter t, because sometimes they have a different parameter, then you have to put in your chain. But in this case, we start with the simplest one. So we have 2 variables by 1 parameter. So this is the chain looks like. Or you can have some of you will use this one, but because of you have the same parameter, then you just put like this. So also possible. Okay, now how to have a del whatever d. Sometimes you need to use del, but sometimes you need to use d. So how can we get like that? Okay, so look at here. As I mentioned before, Z is the boss, right? So who is under the Z? X and Y. There are two people, two variables, so they are sharing. So meaning that because of they are on the same level, so they should have something there. Because something we want to relate with the derivative, so we have partial. So now we are thinking about derivative. So derivative Z to X, derivative Z to Y, because they are on the same level, so we should use del, which means that partial. Okay, so then you put del Z over del X, and similarly for the Z to Y, you have del Z del Y. Okay, so next we go to we done for X and Y. So now look at under or below the X and Y. T, right? Just single T, one person. It is not, they are not, this guy is not sharing with other people. So from X to T, now we are thinking about derivative. So because just single thing, so we use D, not del. Remember I told you how can we differentiate the del and the D. So del is for more than one variable or parameter. D is for single variable or single variable or single parameter. So now from X to T we have D, dx over dt. Similarly Y, dy over dt. Or maybe you want to have a simpler form, it's also possible. So let's say you want to have you don't want to use del, sometimes it's a bit messy, right? So you can just put zx, and this one zy, yt, and then xt. Also possible. Okay, now we done determine all the derivatives, partial derivatives or just regular derivatives from the given variable and parameters. So now we want to construct, this is chain. So we just develop the chain. So from the chain you can have the rule. Then the combination of them you have chain rule. So the rule is you want to get, let's say as stated here, I put D instead of del because of under the Z there is only single T, one T. So that's why we use dz over dt. Okay, so what is the formula? Okay, this is the way. Now because of, you can see from the chain it's split into two, right? It's split into two, so meaning that you have in your rule, in your formula, you should have two terms, which one is belongs to everything belongs to X, and the second one, the second term, everything belongs to Y. It's just like you want to go to T, okay? You are here. So this is the ideology. So you are from here and you want to get through T. You want to go here. You want to go this. Okay? And then how can you get here from Z? You have two paths, right? Which is from this path and other one from this path. So since you have you can use two paths, then in your rule you must have two terms. So the first terms, which is you want to go from Z to X, then you have to pass through this. So Z to X, you have to pass through del Z del X. And then because you are on the same path, then we just multiply. And then from X to T, you have dx over dt. Now, we're done for the first path. And then we go to the second path, plus. That is second term. So now we focus on this side. Just this side. Okay. So, Z to Y, you have del Z over del Y. And because they are on the same path, then we multiply. And then from Y to T, you have dy over dt. Okay. So, then, we done. So, this is your chain rule. Okay, so, if you still confused, because I know that for the first, as a beginner, you still confused, no idea why you should do this, why we should do that, then you have to replay my video again and again. Okay. So this is only one example. I will show you another more interesting example, and which will give you more longer chain rule. So this is how we get this one. You can see they have the same, right? Okay, from how can you get this? From the chain that you develop. Okay, so in order to use this, now we want to look at the example. How can we implement that chain rule? So now you are given your function is okay. Majority of my students, they can do this very well, so it's not so complicated compared with sketching, right? The sketching is sometimes make you feel down because you cannot sketch very well. Okay, so that is your function provided. Your function is in terms of xy, but then your x is in terms of single t, which is t squared, and then y is t cubed. So the question is asking for dz over dt. So this method is called chain rule. So the application here is this one. Okay, so you want to solve this by using chain rule. Okay, so as we have in the chain rule that we have here, so now you have to find out zx, zy, dx, and dy, dt and dyt. So now you have f, because now we have f, not z, so we use f. So fx and find fy, and then you need to get xt and then yt. So that is 4 things that you have to plug in to your chain rule. So f of x. So you differentiate your function here with respect to x, y constant. Y constant, so y4 constant. So now you need to differentiate only x cubed. So you have 3x squared y4. And then for fy, x constant, so x cubed constant. So now you differentiate y4, you will get 4y cubed x3. Okay, now xt, which is you have to differentiate x with respect to t, since you have only single parameter, so you have 2t. And then y, you have 3t squared. And then you plug in all the component that you obtain. So now your fx is, or zx is 3x squared y4 multiplied by xt 2t plus y, so 4y cubed x cubed yt, so 3t squared. Okay, so now you can see the combination of x, y, t. Okay, so you might wonder, do we need to simplify? If we need to simplify, what is our variable that we should provide? Okay, so in this case, normally we ask you to simplify, and sometimes in the instruction they don't mention to simplify. You have to understand, you have to note about that. Every time you do this particular example, then you have to try to simplify. Okay, so what I mean by simplify, you have to make sure your final solution should be in terms of only t, because of you have dt here. So we asking you to provide dz over dt, meaning that your final answer should be something in terms of t. Okay, so then how can you find or change everything here into t? Okay, so in this case you have x and the y. So how can you obtain the t? You just use the given function, which means that you have, okay, at the moment you have 60 and then x cubed. X cubed is x square, so you t square square, and then your y is t cubed to the power of 4. So that is the first term, and plus 12 t square, and then y cubed, so t cubed multiplied by x cubed. So t square cubed. So for this, you have to be careful about the index here. Okay. So when you have the power and the power and the power and the power, and then you should multiply. So because this is the common mistake done by majority of the student, they will just make an error for the indexes. So you have to be careful. Okay, so t square square, then index multiply power, the power, and the power and its power. So it should be multiplied. And similarly, 3, 4, you got 12, not 7. Okay, be careful. And t squared, and 3, 3 will get 9, not 6. And this 1, 2, 3 will give you 6, not 5. Okay, and then we simplify. You got 17 for the power 17. This is also 17, and then because they have the same index, so you can just simplify. So that is the answer. So your final solution should be d(z) over dt is 18t to the power of 17. Don't give me this. So if you give me, then maybe you can lose 1 mark maybe, or 2 marks. Okay. Okay, my question is regarding the question for this one. Differentiate the f where f is given, where x is number of t, y also in terms of t. Is there any other way without using chain rule? So for us can solve this example. So the problem here, you want to differentiate f respect to t. Do you think we have any other method to differentiate z respect to t or f respect to t? Yes, we have another method, but without using chain rule. What is the method? What is the method that we can use? What you can do is, so let's say this is fxy, okay, which is in terms x squared, x cubed, y4. And you know that x is t squared and t cubed. So first you can just substitute all the x and y in terms of t. So you got t squared, so t squared cubed, and then t cubed to the power of 4. And this will give you t6, t12. So you got t18, right? Okay, and that is your function z in terms of t. Now they ask you to get dz or df or dz, whatever, because this one is f. Actually z is also f. Remember I told you before, z is actually f. Okay, this instruction is not, for me, is a bit confusing. So in exam, we make sure that we put the z in front here. So dz, or zt, you can also put zt. So when if you want to differentiate, z, this is z, but in terms of t, then you want to differentiate z with respect to t, so you just directly differentiate. So you have 18t to the power of 17, and the answer will be the same. And this one is more simpler, right? But in this case, you have to understand the objective is you want to learn about more complicated chain rule. So now you want to use the chain rule to solve your problem. So what I want to say here, if in exam you provide me this, because the question normally using chain rule, determine, or they will give you like this, and find dz over dt using chain rule. So normally the instruction is very clear. Using chain rule, they will state that using chain rule. So you have to use this. So if you provide me all these things, and let's say the mark is 5, so you will get 5. But let's say you've forgotten, you don't read the instruction correctly, or you just forget to read the instruction carefully, so you miss the statement of using chain rule. So you just directly differentiate, but first you substitute all the x and y, right? And then you use this method, and then if the total, the marks is 5, then I just give you 1. You cannot get full mark even though you provide me the correct answer because you are not following the instruction. This one you solve without using chain rule. So hopefully you understand. Okay. So this is also correct. This is also correct. But the objective is to learn about chain rule. Okay. So this is another example that you can try. So because of the type of function, we have two variable function and there is only single t and find desired. So the formula should be the same. So your chain should be the same, the chain rule. Okay, so meaning that okay, you might wonder, do we need to provide this in the exam? Okay, for information, there is no mark for constructing the chain, but it is very helpful if you provide, because there are many more formula which are not given. Okay, in this formula is only for differentiation and integration, but other than that we don't give you. So meaning that, so don't waste your memory storage. Okay, so if you feel that you can just understand without memorizing, then you this is actually very will take you just a few seconds to develop this, or maybe you can just develop in your mind and you can just pop up this one. Actually it's easy to see the pattern, okay, without sketching this, I mean without build this chain. You can also easily construct the chain rule. So you see the pattern here, right? You have z, x, and the next should be x. You can see the x and the x. Now, how can you know that your chain rule is correct? Z, x, and then continue with the x. Okay, and then z, y, and continue with y. So if you just provide me dz over dx and suddenly you put dy over dt, so that is wrong. Okay, just like if you have a more simple form, you have z x x t plus z y y t. Okay, that is only for two variable, but if you have three variable, how can you obtain that? So of course you need, because you have extra variable here. So for extra variable, so now you don't have z anymore, you have w. For three variable we have w. So w, under the w, you got three people here, x, y, z. So you need three paths. So you need, when you have three paths, meaning that you have three terms. You have to add one more terms here. So this one is belongs to w, wx. This one belongs to wy and plus wz. So that is, let's say here, I give you how to construct. So here w, under the w, there is x, there is y, there is z. So x in terms of t, y in terms of t, z in terms of t. So you got one parameter. So you have wx, wy, wz, xt, yt, zt. And then your let's say dw over dt is wx xt plus wy yt plus wz zt. And actually you can see the pattern here without this one. Also possible, because normally there is in rubric for the answer scheme, there is no mark for this chain, just to help you to make sure you, just for your own checking, because you want to make sure that your formula or your chain rule here is correct. So that's why we need to have this. Okay, so this is for three variable function. Yeah, it's not in the example here. Okay, now I just talking about the three variable. So this is it. Okay, so now look at the, you see here the formula wx xt, wy yt, wz zt. So we got that. Okay, now look at the example. Okay, so this one, okay, you have to find dwdt. Why we have d? Why we use d or not there? Because there is only single parameter. Okay, so w is x, y, z, and x is t cube, y is t square, and z is t4. Okay, so if you want to find out dw dt without chain rule, it is easy. Just substitute all the x, y, z here and then you just differentiate. But now we want to use the chain rule as mentioned here. Find dw dt by using the chain rule. Okay, it's stated there. So the formula w x xt plus wy yt plus wz zt. Now you have to differentiate. Okay, find out wx differentiate. Okay, now about the differentiation of three variable function. The same idea for two variable function. Once you want to differentiate respect to x, so y and z are constant. Okay, so here yz constant. So now we focus on only x and you want to differentiate x respect to x. It will give you 1. So the answer is y, yz. Okay, and wy, so x, z constant. X and z constant. You only have y, differentiate y, you got 1. So the answer is x, z. Wz, xy constant. Now we have only z, differentiate z, you will get 1. So the answer is xy. Okay, and then xt, yt, zt. Xt, 3t square, 2t, 4t cube. Okay, now the time for us to substitute all the terms. You got 6 terms. You need to multiply. So wx, which is yz, xt is 3t square plus wyz, and yt is 2t plus wz xy, zt is 4t cube. So we want to leave our answer in t, then we have to simplify. So 3t squared, so your y is t square and z is t4. Okay, so now x t cube t4 and 2t. So plus t cube t square and 4t cube. So now no power, just a 4, so plus. Okay, 2 plus 2 plus 4, then will give you 8. And this one 2, so 4 plus 1, 5 plus 3, 8. And then 4, 3, 3, 2, also 8. Then you will get 9. 98. Okay, using chain rule. So you can see that using chain rule is a bit longer. But since our objective is to use the chain rule, then that is the way that is the thing that you have to go through. Okay. So next we will look at more. We have two variables now. I mean 2 variables, but each variable contains 2 parameters. Okay.